In this video, we will be seeing how to optimize the foundation designs using MIDAS Gen. Okay. So first we'll perform the analysis and then we'll check the load combinations for the concrete design where we'll be having the strength as well as the serviceability. Or we can also auto generate the load combinations by replacing the existing load combinations, and here we can select the design code and we can just click on OK. So the load combinations will be created here. And now in apps we have some special tools. So design plus tool helps in the optimization of the RC members. Okay, so now if you want to design the isolated foundations, you can just select the nodes where we want to have the isolated foundations, and this is the design plus tool where we can optimize the design. So initially you can go to the MIDAS link, and here we will get a Gen NX, and we can select the file and hit on the connect. So it will be successfully linked with the Gen NX. Now we can select the member and we can also link with the database of that particular model. So all the design codes, materials, rebars will be updated here. And now we can select any of the member, let's say isolated foundations, and we can do the settings here by just hitting on this three dot, and for footings we can link by member. So for each column we will be getting separate of forces and the components, and here you can select all the load combinations and the force type. Either we can take design forces of the columns or the reactions of the supports. Okay, if you are doing only the analysis, we can just take reaction of the supports and click on OK. Now in Gen NX you select the nodes of all the isolated foundations, and that will be updated here, the node numbers for the foundations, and we can import all the data, analysis data from the Gen NX. So now if you see in the tree menu for the footings, all the data has been updated for almost 13 footings. So for each footings, all the strength and the serviceability load combinations are imported here. Okay. And now initially we don't know what is the size of the footing required, so let's, by default it will be 3 meters by 3 meters, and here we can do some optimization settings. If we go for the RC1, there we can change the size of the section, and you can also have adjustment on maximum limiting thickness of the footing. And rebar data, so for rebar data you can just select the code ASTM American standards, and for in RC2 you can find the foundation, so you can select any rebar between 3 to 18, and you can also have the spacing criteria. So once we have done this, we can also do the design or check individually, and or we can go to the member list and we can all select all the members, and we can do the design in a single go. So initially if we see here for the foundation members, the size of the footing is 3 meters and 3 meters. So once I hit on design, then it will automatically suggest what is the size of the footing required, and you can also generate the drawings in one click. So here you will be getting what is the size of the footing LXLY and the soil bearing capacity, and here you can generate the quantity of the steel, so total rebar and total concrete in the, you can change the units to mm meter cube, and this is in newtons. And finally you can just generate the report in any format required: Word, Excel, text formats.